All right, happy Wednesday. Please have assignment number 102 out on your desk and make sure that you have submitted that. You may want your notes packet out. We're not going to be taking notes today, but you may want that out to refer back to. We're going to look at the angles, Desmos on angles, and then we are going to kind of focus on algebra in regards to complementary and supplementary angles. So as we begin, I just want to also remind you that if we do get snow tonight and for some reason we're canceled, please go to Canvas, go to our home screens, find our Zoom link. You are going to be required to Zoom. We won't overwhelm you with things. Make sure you have your notes packets at home for tomorrow and your iPads, all of course, and make sure you jump in on the Zoom if we are out. Okay, now these are examples of answers, and so I'm not going to go through a ton of these, but just real quick, adjacent would be like, I don't know if I numbered these the same on the worksheet or not, but angle 1 and angle 2 would be adjacent, angle 2 and angle 3 and angle 4 and angle 1 and angle 4, and then vertical angles are the ones that are always opposite of each other, so angle 1 and angle 4, angle 3 and angle 1 would be vertical to each other, and then over here you go 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and 1 would be all adjacent angles. And then there are more than what we see here, but we would have angle 1 and angle 4 are vertical to each other. Angle 2 and angle 5 and angle 3 and angle 6 would be vertical to each other. As we look here, this question, neither. They are not opposite, okay, because those were not two straight lines that intersected. And so vertical angles are always equal in measure, and they're not adjacent because they're not next door neighbors. The second one, those are adjacent because they are next door neighbors. They shared a vertex and they shared a side or array. And then the last one, 145 degrees and 145 degrees are vertical because they're opposite and they're equal. Number 3, those are vertical angles. They're referring to the 90-degree angle and the x, and so they're both 90 degrees, and those are vertical. The number 4 would be adjacent. They're next door neighbors. They're also supplementary, but that is not an answer choice that you were asked or given. And so in this case, they create this straight line, so therefore it's 180 degrees. So x plus 85 equals 180, and subtract, you get 95 degrees. These are vertical, and they would be equal to each other, so 128. On to the back, you add those to check, and 26 plus 64 is 90, so they're complementary. Remember, C comes before S in the alphabet, and 90 comes before 180, so the 90 goes with the C, and the 180 goes with S to help you remember between complementary and supplementary. The number 2, this created a nice, neat straight line, which is 180 degrees. You add those two together, you get 180, so that's supplementary. Add these two angles together, and you get 89, which is extremely close to 90, but not 90, so therefore they're neither. This is where it gets a little bit confusing because you're dealing with always, sometimes, and never questions. And so x and y are complementary angles when both x and y are always acute. If x and y are complementary, then both x and y are always acute. Well, if it's a 90-degree angle, right, it doesn't matter what you draw for your third angle or your complementary angles. They always have to be acute because two acute angles would have to add up to 90 degrees. You can't have an obtuse angle add up to 90 degrees, so therefore it's a never. If x and y are supplementary, that means they add up to 180, then x is sometimes acute. So if you look over here to my examples that I sketched for you, that would be an example where x is acute. The second one, x would be obtuse, and therefore it would be sometimes. All right. If x is a right angle, then x is never acute because if you're a right angle, you're exactly 90, and to be acute, you have to be less than 90. If x and y are complementary angles, then x and y are sometimes adjacent. So the examples that we've been drawing most of the time, they are adjacent, but here would be an example where they're not adjacent, where they're separated, but they add up to 90 degrees, just like question number 1 up above. Number 8, x and y are supplementary angles, then they are sometimes vertical. There is only one example where they could be vertical, and that would be when you have perpendicular lines, as we show here, where they have 90-degree angles. And so that would be an example of the sometimes vertical. All right, and number 9, they are showing you vertical angles because they're opposite of each other, and so they're equal, and so it's 128. This is complementary. They add up to 90 degrees, and so you show the math. X plus 35 equals 90. Subtract 35, you get 55, and then we have our supplementary angles. Now, you're going to subtract 117, and it gives you 63. All right, so we're now going to apply and practice some of this. So we're going to end up going to Canvas in class today, and I want you to click on the Desmos activity. We're going to do this together. I'm just going to quickly show you on the video what you're going to be doing a little bit, but you're going to walk through these 20 slides. Don't take too long, and then we're going to jump into some notes. And so you have slide 1. You're going to sign in as a guest. You don't have you're not using any kind of password or anything. You're going to do the guest deal and just put your name in. Up here, you're hitting next. And once again, you can use the little AA button to make it larger or smaller if needed. Those talk about the types of angles. Then this one talks about adjacent angles. And what do you notice about adjacent angles? What I like about this one is it talks about adjacent angles, and when we move the angles, you see what kind of happens. And so we can change these items. Then we get to these 2 adjacent angles sharing. And so we're going to end up going ahead and noticing in this case they're asking you what's the bigger angle, A, B, D, and so you kind of put them together. As we go further along, we have a 90-degree angle, and we're going to talk about kind of putting these together and thinking about what would the value of X be. Here you have supplementary angles, and we're going to start. What I like about this is it shows you supplementary angles add up to 180, as we talked about yesterday, and what happens is no matter what I do to this angle, when you look at the other angle and put the 2 together, you can see that you're always going to add up to 180. And so you can kind of see what's kind of neat about that. It gives you a good visual. And so it's going to have you do some math with it. And then we can kind of continue to go through. So it's talking about those adjacent and supplementary angles at the beginning. And then we get into complementary angles, and we know complementary angles always add up to 90 degrees. And so you can visually see it. So basically, I'm going to have you step through that. We're just going to investigate together. You're not submitting anything for that. And then we're going to jump back, and now we're going to hand out the reteaching lesson 9.5. And so adjacent angles, once again, share a common side and has same vertex. Complementary angles, what I like to do with this is I always like to write it out like this. Angle 1 plus angle 2 has to add up to 90 degrees. And so this is the setup that I want you to see. Supplementary angles, angle 1 plus angle 2 equals 180 degrees. If you get used to setting this up, then you just have to plug in numbers. And then your equation for this one with vertical angles is it's going to be your angle 1 is equal to whatever your angle 2 is. And so you're going to set it up this way. And you're going to see we're going to start applying some algebra to this. So down below, we're going to look at 3 examples, and then your job is going to be working on some homework. And so step 1, we're supposed to classify these angles. And as we look here, we're referring to 2x, and we're referring to 43. So these are opposite of each other, so they are vertical. Well, if we go back in our notes and we talk about vertical angles, we know have the same measure, okay? Same measure, and this is the setup we're going to use. And so I'm going to go ahead and I'm going to put angle 1 is equal to angle 2. So in this case, my angle 1 will use 2x, and 43 is the other angle. They're equal to each other, and oh man, now we have to deal with Elsa. And Elsa wants to be all by herself, and so I'm going to rewrite this real quick. So I have 2x equals 43. And 2x means 2 times x, so to undo multiplication, you're going to divide both sides. Now, you may use your calculator, and you can get your 21.5, or you could write it as an improper fraction and so on. But so x is 21.5. And those are vertical angles. We look at the next one, and we should notice that this is a nice, neat, straight line. And so we know that these are supplementary angles. Now, if they're supplementary angles, then we're going to do our setup once again. So it's going to be angle 1 plus angle 2, but this time has to equal 180 degrees. So now, angle 1, we'll call this one, which is x plus 34, And angle 2 is this one, was just x. Oh boy. Now we get to go into our combining like terms. And so we have an x, and we have another x, and then we have 34. So I'm going to bring these like terms together, and that gives me 2x plus 34 equals 180. And I know some of you are loving the fact that what we did first semester is now applying to this semester. So we have to undo addition and subtraction first after we combined our like terms. Now we're left with 2x on this side because we subtract 34. I subtract 34, and that's going to give me 146 if I'm doing my math right. Now that's 2x, so I'm going to now divide both sides by 2, and that's going to give me x equals 73. And you're allowed to use your calculator as you're going through this. So in this case, we had to combine like terms because we had more than one x, and then we undo our addition and subtraction first, and then undo our multiplication and division. Next question, we have a 90-degree angle. And since we have a 90-degree angle, I know that these are complementary angles. And the setup for complementary angles is angle 1 plus angle 2 equals 90. So in this case, my angle 1 is x plus 7, and angle 2 is going to be 22 degrees. Now, we don't have more than one x, but I do have two constants here, so I can put those two together and make things, in my mind, at least a little bit easier. So positive, okay, plus a positive, I'm going to have more positive, so I get 29. And I am going to subtract 29 from both sides. And that's going to give me x is equal to, and so we borrow, and you have your calculator, but 61. And it's not 61 degrees technically, because if I wanted the measure of the angle, then I would put it in. So the angle measure is actually, 68 degrees, because if you plugged it back in for x, that would make it true then, because 68 degrees plus 22 degrees gives you 90 degrees. All right, so now what you're going to do is you are going to, excuse the extra page, but you're going to go to assignment 103, and you're going to, you flip your paper over, and assignment 103 is this back of your worksheet. So your job is to go ahead and work through these problems. Now notice these first few are just naming, the next few are just naming, and then here you are going to name one of these three things, and then I should see if they're complementary. So complementary, you're going to do this plus this equals 90. That's the setup I should see. If you say that they are supplementary, then I should see this plus this equals 180. And if you said they're vertical, you're going to say this angle equals this angle. And then you're going to solve. All right, so that is your assignment. And once again, if there is snow and school is canceled tomorrow, you need to make sure you hop on the Zoom, and I will talk to you tomorrow. Have a great day.